Okay, so we're going to look at, first let's look at some numbers that look like this. Say like 3 plus the square root of 2. So it's a rational number.
Plus an irrational number.
Plus, well, not just any old irrational number, plus the square root of 2. Or I might look at later a number like 5 minus 2 times the square root of 2. Or something like that. Actually, later is right now. Okay. Can you add those numbers together?
Well, you made 3 plus square root of 2?
Yeah, what if I asked you to say, what is 3 plus the square root of 2 plus 5 minus 2 times the square root of 2?
Well, if, maybe you could add, but you could add, maybe that would be 8.
8, because you added the 3 and the 5?
Yeah, and that would be the 3 times the square root of 2. 8 plus 3 times square root.
Well, how many square roots of 2 do I have on this side?
You have one square root of 2.
And how many on this side?
You have minus 2.
Minus 2 of them.
So minus 1 square root of 2.
Right, so I get 8 minus the square root of 2. So I made up this new number that's a kind of a complicated looking number, and I made up this number that's kind of a complicated looking number.
Yeah.
And I could just add them together.
Cool.
That's pretty neat, right?
Yeah.
Now you ready for, I'll give you a challenge. What happens if I multiply these numbers?
Well, it would look sort of like a quadratic. You've got 15. Well, actually, it's plus minus 6 times the square root of 2 plus 5 times the square root of 2. And then you've got the square root of 2 minus 2 times the square root of 2 times the square root of 2. So it's minus 2 times the square root of 2 times 2.
How did you get that?
This end part?
Yeah.
Square root of 2 times this.
Okay.
Well, I multiplied this minus 2 part first. It's
Times, so you said minus 2 times the square root of 2. And what are you left over with then?
Then you're left with the square root of 2 times the square root of 2.
Oh, I see what you did.
And
Okay.
then,
Just a little correction there. So I have the square root of 2 times, let's just forget about the minus for a second, because we know it's going to be minus, times 2 square root of 2. Okay. But this just means 2 times the square root of 2.
Yeah.
Right? So I get square root of 2 times the square root of 2. That's what that means.
Yeah. Yeah.
Okay. And so how do I simplify this expression here?
Well, you just multiply. You can. It's 2 times 2.
So I can rearrange these terms by what's that property called? Where
It's the commutative property.
okay, so this is 2 times the square root of 2 times the square root of 2. Oops, the square root of 2. This is 2 here.
Yeah.
So this whole thing is 4, and it has our minus sign. So it's minus 4.
Minus 4.
Okay, and how does this simplify?
Well, it's the 15 and the 4 can go together.
All right.
So we get 11 minus the square root of 2.
So it's interesting. If I just have a square root of 2 laying around, it seems like I can add them, and I get other square roots of 2, but I don't get anything else. Like I don't get square root of 3
Yeah.
No.
or square root of 10.
Because square root of 2, it's kind of like an x.
It is kind of like an x. You're right. And then when I multiply them, I also get some square root of 2s, but I don't get anything else.
Yeah, the value of x doesn't change throughout the process.
So if I have a rational number plus some square root of 2, I can add, multiply, subtract, divide, and I always get rational numbers with square roots of 2.
Cool.
Pretty neat.
Yeah.
Let's see what happens with I.
All right.
Okay.
Cool.